Now we're going to simplify higher roots. No longer will they be square roots, they're going to be higher than that. Page where you want to just hit the pause button and just take a look at some things, okay? So one thing I want you to look at is right here, this column is our number, okay? And whenever we square that number, that's what we get. Whenever we cube that number, that's what we get. Whenever we raise that number to the fourth power, that's what we get. When we raise the number to the fifth power, that's what we get, okay? There's nothing really strange about this table right here. Now, but take a look at this one. Notice these are all negative numbers, okay? Notice that whenever you square a negative number, you always get a positive. Notice that whenever you cube a negative number, you always get a negative. And when it's raised to the fourth power, you get a positive. When it's raised to the fifth power, you get a negative. So one thing that you can actually deduce from this table right here is that whenever a negative number is raised to an odd power, you get a negative number. When a negative number is raised to an even power, you get a positive number. So this page is kind of confusing, but there are some vocabulary words on here I want to talk to you about. First of all is the index, okay? So whenever you are taking the nth root of a number, then that is called your index, okay? So if we've got some other number, even if we just had the square root of a number, the index of this would be 2 because what's understood to be up here is a 2, okay? If there is no number right here in the index, then it is assumed to be a 2, okay? If there is a different number, hang on, let me erase this. Let's say I were taking the third root, then my index would be 3, okay? All right, I just was pointing out what an index was. We can't easily take the third root of 4. We'd have to grab a calculator or use a chart. Whenever I was back in the olden days, when I was in school, we had these charts in the back of the textbooks that told us different roots of numbers. And those weren't really all that fun to look things up, but be thankful that you have calculators nowadays. So this number right here, the index, okay? It says here that when n is an even number and a is greater than 0, then you can take the square root of that, okay? If n is an even number and this number is a negative number, so less than 0, then it's not a real number. And we're not going to talk about imaginary numbers in this class, but just so you know, there is such a thing, and some of you may have learned that back in high school dealing with imaginaries. We will not be dealing with them in this class. So if you're trying to take the square root, or if your index is even and you have a negative number under the radical, then all we're just going to say for now is that it's not a real number. We're not going to go into imaginaries in this class. For this page, I want to show you, so part A, we're going to do the third root, or you would say the cube root of 8, okay? And what that means is what number times itself 3 times would give you 8, okay? And so you could say that 2 to the third power is 8, right? 2 to the third power. So what happens is this 3 and this 3 cancel each other out, and you're left with just 2. Okay, so what times itself 3 times would give you 8. Now, remember, I'm also using this calculator, the TI-30X2S, and I'm going to tell you the buttons that you could push to find this on your calculator. So let's do that real quick. All right, so start by clearing your screen, and then you would hit the index number first. So you would hit 3, then you would hit the second button and the caret button. It looks like this. It looks like a rooftop. And then you would hit the 8 button and then hit enter. And you should come up with 2. So remember, that's 3 first. So you do your index first, then you hit your second and your caret button, and then you hit 8 and then enter, and you should get 2. Okay? All right, let's do part B. So on B, we're taking the fourth root of 81. What number times itself 4 times would give you 81? Well, that would be, look, 3 times 3 times 3 times 3, right? 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So this answer would be 3, okay? 3 to the fourth power is 81. All right, again, if you're doing your calculator, you would hit 4, don't hit 3 this time, you would hit 4, then second, the caret button, and then 81, and then enter. And you should get 3 there. All right, let's do part C. The fifth root of 32. What number times itself 5 times would give us 32? Okay, so that's the same thing as, I could write out a bunch of 2's, or I could just say 2 to the fifth power. And remember, those 5's, they cancel each other, so I'm left with just 2. Okay, and if I'm typing this into the calculator, I would type in 5, 5 first, then hit your second, your caret button, 32 instead of 8, 32, and then enter, and you should get 2. One makes us remember that whenever we're taking an odd root of a negative number, we can actually come up with an answer. Whenever we're taking an even root of a negative number, we have to say no real solution, okay? And we're not going to worry about what imaginary numbers, like I said. We're just going to, on part B, we're going to say no real number, okay? Because there is no such number times itself 4 times that would ever give you a negative number. No such number. All right, so let's worry about part A for now. All right, so on part A, we are taking the cube root of negative 64. So what number times itself 3 times would give us negative 64? And that would be negative 4. Remember, because you could write negative 64 as negative 4 to the third power. Okay, and then this 3 and this 3 cancel each other, and you're simply left with negative 4. Okay, and on B, because we're taking an even root of a negative number, we have to say no real solution. Okay, we can't come up with anything else for that right now. You have not learned it. Okay. All right, so on part C, we want the fifth root of negative 243. And I don't know that off the top of my head. So I'm grabbing my calculator. I'm going to type in 5. Then I'm going to do my second button. Then I'm going to hit my caret button. Then I'm going to hit negative 243 and then enter. Okay, so let's do that. And I get negative 3. All right, so this page is a good page for you to write down and have in your notes, especially whenever you're taking a test or anything like that. What this is saying is that when your index is odd, then you're just looking for the root of that term that's under the radical, okay? So if you have a to the n and see how those n's match, then that means that they cancel each other. You're left with just a. But whenever n or your index is even, you're looking for the absolute value or the positive of this term, okay? Because remember, it's undefined if there is a negative under there. And I don't mean what by undefined I mean it's not a real number, okay? All right. So, we typically in your homework though, you won't see the absolute values, just write the positive down. And I'll show you what I mean here in just a second. Okay, so notice on A, there's nothing up here. But we know that if there's nothing there, it's assumed to be a 2, okay? And so if you had this problem in your homework, technically this 2 right here that's not there, but it is understood to be there, and this 2 will cancel each other. And because it's even though, it's even, we want the absolute value or the positive of this x, okay? So our answer would be the absolute value of x, which in your homework, you're not going to put the bars around it. You will simply say x, okay? All right. For 3, I'm sorry, letter B. The 3's cancel, and because it's odd, we don't really care so much about the absolute value, and so we have just n here. Okay, so for number 4, or sorry, C. I keep saying the index as the number. On C, this 4 and this 4 cancel, but remember, because it's even, we're supposed to say the absolute value of P, but again, in your homework, just put P. All right, on letter D, the 5's cancel. We're left just with plain old Y. We don't have to worry about the absolute value on that one because it's odd. All right, so for letter A here, we've got the third root of y to the 18th. Okay, so here's what you want to do. You want to write this so that this 3 cancels that 3. Okay, so what would have to go in here in order for this to be a 3 right here? Well, 18 divided by 3 is 6, right? So this would be y to the 6th, because remember, whenever you have a power raised to a power, those powers get multiplied, right? Okay, so this 3 cancels this 3, and we are left with y to the 6th power, and that is our final answer on A. On B, we want the fourth root of z to the 8th. And don't forget, we want this 4 in the index to cancel something right there, right? So what would have to go up here in the exponent in order for this to be an 8 right there? It'd have to be a 2. Okay, so I've got z squared to the 4th power. Remember, your power raised to a power gets multiplied. So this 4 right here cancels this 4, and I am left with z squared. For this one, letter A, we've got the third root of, let's see here, 64p to the 6th power. So what times itself 3 times would give us 64? Well, that would be a 4. Don't forget what I taught you about your calculator, how to type that in. So you would type in, if you needed to find that on the calculator, you would hit the number 3, and then you would hit the second button, and then the caret button, and then let's see here, which button is that? Oh, then 64, and then enter, and you should get 4. And then this part right here, I don't know if you've realized this yet, but really what's left out right here is this number divided by this number. There you go, you're done. All right, so on part B, we've got the fourth root of 16q to the 12th. So you would have, what number times itself 4 times would give us 16? That's a 2. And then we're going to do this number right here divided by that number, and we would get q to the 3rd power. Now, this one does require absolute value bars right here, because it is possible that if q were negative, that we would end up with a negative number, okay? So if it were squared, it wouldn't matter, all right? Because remember, numbers raised to the 3rd power, if it's a negative number, could end up being a negative number, and we can't have a negative under this radical, okay? So that's why we have to have our absolute value bars on this problem. Now, on the homework, if you're typing this in, I don't believe that they'll give you the option for the absolute value bars, but I also don't think that there's problems like this in the homework, but I just want to make sure that you're aware of this for future classes. This page is just a reminder. of what you've seen before. So, but it's actually telling you that if it's the nth root, it still works the same as if it were a square root. Okay, you're still allowed to pull them apart, but your root stays with it, or your index stays with the square root symbol. Okay, and so vice versa. They're just showing you that. So, for part A, we're allowed to write it like this: the cube root of x to the third times the cube root of x. Okay? We're allowed to split it apart. And remember, I did that because this cancels this. So I'm left with just plain old x right here times the cube root of x. And there we go. We're done. And by the way, this dot right here may or may not be there. So it could look like that, or it could look like that. Either way, it's the same. All right, let's look at B. So now we have the fourth root of, let's see here, let's do x to the fourth in this one, times the fourth root of x to the third. Because remember, whenever you're multiplying your bases, you add your exponents, okay? So this 4 and this 4 cancel. I'm left with just plain old x times the fourth root of x to the third, or it could be written like this. Okay, either one of those work. Do we need the absolute value bars? Yes, because it would be possible for something to the first power to be negative. So we want the absolute value, okay? Again, in your homework online, you're not going to have that option, and I don't think you'll have problems like this, but I just want to point out that they would be necessary for this because something to the first power technically could be a negative number, okay? And we don't want that because we can't have that under the radical. All right, so these are problems that if you try to type them into your calculator, you're going to end up with decimals. And what if I don't want you to give me the decimal? What if I just want you to give me the simplified version of this? Well, that means that you're going to have to figure out how to do that, okay? And so here's what I recommend. I suggest that you take the number that's under the radical and make a factor tree and write it as a as primes, a product of prime numbers, okay? So we've got 2 times 8, 2 is prime, 2 times 4, 2 is prime, 2 times 2. Okay, so we've got 4 2's, right? And we only want the cube root of 16, which is 2 to the third power times 2, right? And so this 3 cancels that one, but I'm still left with 1, 2 that's under that radical. So I've got a 2 on the outside. I've got a 3 in the index. That doesn't go away. And there we go. All right, let's try that with 243 though. Let's see here. I know 3 will go in that. So 243 divided by 3, 81. And then I've got 3 times 27, I believe. Yeah. And then I've got 3 times 9, and then I've got 3 times 3. All right, so we've got how many threes here? 1, 2, 3, 4, 5. I've got 5 threes. So this could be written as 3 to the fourth times the fourth root of 3, right? Okay, and then this 4 and that 4 get rid of each other. So I'm left with 3 times the fourth root of 3. And that's it. Here, strongly recommend that you just make factor trees out of these. So 24 can be written as 2 times 12. 2 is prime, 2 times 6, and then 2 times 3. Okay, and let's see here. So on part A, I have the third root of 2 to the third power times the third root of 3 times, don't forget your x's here, x to the, let's see here, oh, don't forget your 3 up there, sixth power times the third root of x, right? Because we have a total of 7 x's. Okay, so I can take the third root of that. I can take, and then that becomes 2, so I'm left with x squared there. So I've got a 2 on the outside, that's from that one. I've got an x squared on the outside, and what I'm left with under the radical is 3x. Part B. Okay, so on part B, 80, I'm going to do a factor tree for 80. Oops, let me erase that line. There we go. All right, so I've got 2 times 40, 2 times 20, 2 times 10, 2 times 5. Okay, so I can rewrite 80 as the fourth root of 2 to the fourth power times the fourth root of 5. Okay, so I've got those 4 2's right there. I've got that 5 right there. I'm also doing times the fourth root of y to the 12th. Now, why would I choose 12? Well, because 12 is the biggest number that 4 will go into. It won't go into 13, it won't go into 14, okay? And so fourth root of y squared would be left over. Remember, this plus this have to add up to that number right there, okay? All right, so now I can take the fourth root of that and that. I could take the fourth root of that, and this becomes 3, and then those fall out. So I'm left with 2 on the outside. I've got y to the third on the outside, and then I've got the fourth root of 5y squared. Now, do I need an absolute value here? Is it possible for this right here to end up being a negative number? Yes, because it's got a 3 up here, okay? And remember, we're taking the fourth root, and because this is odd, we need to make sure that we have the absolute value of this y. So that's why there does need to be absolute value bars around this y right here. I know this is a concept that is tough to get. You'll get it eventually. It'll come to you. But the key happens to be whenever you have an odd root, but you're taking an even index, okay? So always think about that. If you end up with an odd exponent on the outside of the radical, but your original problem has a even number in the index, that's when you're going to have absolute value bars. Oh, by the way, and it also has to be around the variable, not around the numbers. All right, so now let's take a look at some of these negative numbers that I've been talking about this whole time, okay? So can we take the third root of a negative number? Yes, remember, because it's odd, okay? And so there is a negative number that when it's multiplied times itself 3 times gives you negative 27, all right? Negative 3 times negative 3 times negative 3 gives you negative 27. So our answer to A is negative 3. Now, take a look at part B. Check this out. Is there a number times itself 4 times that gives you negative 16? Well, if you have 4 negative numbers, don't the negative signs all cancel each other out? Yes, so this answer would be not a real number. That says real, I swear. Okay, all right. I hope that makes sense. You have the quotient property the quotient property you already learned with the square root still applies no matter what the index is, okay? It's also still telling you that that your denominator can't be 0, okay? This one, I just strongly recommend that you simplify where you can. Sometimes it helps to simplify first. So like this would be a to the 8th divided by a to the 5th. Remember, you subtract your exponents when you have the same base. So you would end up with a to the 3rd power, and then these 3's cancel each other, and so you're just left with plain old a. All right? All right, on B, you've got the 4th root of, and remember, subtract, so we've got a to the 8th power, and then the fast and easy way is to take this divided by that, and you get a squared as your final answer on part B. All right, so these are just getting a little bit tougher. So let's go ahead and write A as the cube root of -108 over 2. Because remember, we're allowed to do that. We're allowed to combine these. As long as they have the same index and they're both under the radical, we're allowed to do this. All right, so this would be the cube root of -54. Now, I'm going to ignore the negative just for a second. All right, and I want to write 54 as a product of primes. All right, so I would have 2 times 27. 2 is prime. 3 times 3. No, sorry, 3 times 9. Sorry, and then 3 times 3. Okay, and then don't forget we've got our negative in here too. So could these be negative? Yeah, totally. Okay, so let's see here. Now we've got the cube root of -3 to the third power times the cube root of 2. Remember the 2 that was up here at the top, right here? Okay, so now I can take the cube root of -3 to the third power. The 3's cancel, and I'm left with -3 times the cube root of 2. So that's part A. All right, let's go ahead and go down here to part B. Fourth root this time, so we need to remember that if we end up with an odd variable, odd exponent on a variable, that we need some absolute value bars, okay? All right, so let's keep that in the back of our mind for later, but for now, let's write this like this. 96x to the 7th over 3x squared. All right, so now let's simplify. So I want the fourth root of 32, right? Yep, x to the 5th. All right, so now I'm going to do a factor tree for 32. 2 times 16, 2 times 8, 2 times 4, and then 2 times 2. So that would really be 2 to the 1, 2, 3, 4, 5th power, right? Okay, so I can rewrite this as the fourth root of 2 to the 4th power times the fourth root of 2. Okay, remember that we had to have 5 total. And then also times the fourth root of x to the 4th power times the fourth root of x, because we needed a total of 5 of those as well. All right, so now I can take the fourth root of this one and I can take the fourth root of this one, and then these two are going to be left under the radicals with an index of 4 when we're done. And so what would this be is that cancels that, and that cancels that. So I've got 2 and x, but don't forget, now that I have a odd exponent, because remember that's a 1 up there, and we were taking the fourth root, I need the absolute value bars there. Okay? All right, there we go. Now we're done. All right, so now let's look at part A here. So we're taking the cube root of 24x to the 7th over or divided by y to the third power. Now, I can't simplify anything under this radical, so it won't really do me any good to have it written in this form. So it might just be easier to write it like this. The cube root of 24x to the 7th over the cube root of y to the third. Okay, so now I know I can reduce that. That's cool. All right, now let's write that numerator in a form that will help us. All right, so again, if we have 24 off to the side here, I'm going to make a factor tree. So I have 2 to the third power and then 3 to the first power, right? Okay, so let's write that numerator in a better form. 2 to the third times cube root of 3 Okay, so I took care of the 24. Now let's take care of the x to the 7th. Times the cube root of x to the 6th. Why did I write it like that? Because 6 can easily be divided by 3, right? Okay, and then I need one more x under the radical. Okay, and then in the denominator, I'm just going to go ahead and simplify that. So we've got just plain old y. All right, now I can reduce that, and I can reduce, that'll become squared though. Okay, so I end up with 2 on the outside. I've got x squared on the outside. That's where this came in. And then I've got the cube root of what's left over under the radical. I've got a 3 and I've got an x under there, okay, over y. And because we're taking the third root, an odd root, we don't have to worry about the absolute value bars here. All right, so now this problem is complete. We're done. All right, let's go on to B. All right, so let's see here, we'll do that in purple. All right, so on part B, we have the fourth root. Got to be careful in this one. I'm just going to rewrite this already just to save some space, because again, this one we can't reduce anything under the radical. There's nothing we can reduce. So let's write it as two separate roots. Fourth root of 48 x to the 10th over the fourth root of y to the 8th. Okay, so again, off to the side over here, I'm going to make a factor tree. That's a 3. All right, so I get 2 to the 4th power times 3. All right, so we're going to rewrite the numerator as, let's see here, the fourth root of 2 to the 4th power times the fourth root of 3, because remember that's what I had left over. And then I'm going to go ahead and erase my factor tree just so I have some space. And then I've got the fourth root of, let's see here, what's a number smaller than 10? Because 4 won't go into 10 evenly, so it'll be 8. We're going to do x to the 8th power times the fourth root of x squared, okay? And the reason why I did x to the 8th is because I can easily divide this number by 4 and get a whole number answer, okay? Now, down here in the denominator, I'm going to go ahead and reduce that, okay? So, or simplify it, I mean. So we get y squared in the denominator. All right, now I'm going to scoot this up. I can go ahead and I can take the fourth root of this right here. Remember, these 4's cancel, so I'm left with just 2. And right here, this becomes x squared, okay? And those are going to be on the outside, all right? Okay, so we've got 2x squared, and then what's under the radical is 3 and then x squared also, okay? All right, and then we've got y squared in the denominator. Now, think about this. Do we need the absolute value bars, okay? Because remember, we had the fourth root, so we do have an even root, so it's something we need to think about. But look at our final answers on the outside. We've got even numbers on the outside, so we're totally okay with not having absolute value bars on this problem, because remember, something squared can never be negative, okay? So this is our final answer here. All right, so whenever you add and subtract higher roots, you will need to be very, very aware of if you have like radicals or not, okay? And so you need to understand this right here. Radicals with the same index, that's that number up above the radical sign, and same radicand, that's the number under the radical, are like radicals. And in order to add and subtract, you have to have like radicals. All right, so on part A here, check out the number. The very first thing you should look at is the index. Do they match? Yes, they do. Okay, then you have to look under the radical. Do those match? Yes, they do. Okay, so we're allowed to add these together. Now, you do not add what's under the radical. That is like a variable. It stays just like that, okay? What you add is the numbers that are considered the coefficient. So this has a 1 out front, and that also has a 1 out front, okay? We don't write them, but they are there, okay? So we would add the 1 plus the 1, and you get 2, and then nothing under the radical changes. So you would have the 3 as the index, and then 4x. So this is the answer to part A. All right, let's look at part B. All right, again, look at your index. They do match. Look at what's under the radical. They also match. So what you subtract in this case is the 4 and the 2. So 4 minus 2 is 2, and then nothing changes, the index or the radicand. Do not change. Okay, so let's look at A. This is A, and you look at that and you're like, well, I can't do anything with that. Well, you can't definitely in that form, but maybe we could simplify this and it'll turn into something that we could subtract. All right, so again, I'm going to make a factor tree with the number 54. So 2 and 27. Then I've got 3 and 9, and then I've got 3 and 3. Okay, so this turns into, 54 turns into the cube root of 2 times the cube root of 3 to the third power. Oh, well, that'll simplify, won't it? Okay, so now let's do the same thing for 16. I'm going to make a factor tree over here. 2 times 8, 2 times 4, 2 times 2. So then the cube root of 16 turns into, let's see here, the cube root of 2 to the third power times the cube root of 2, right? Because we have a total of 4 2's here. Okay, so then this ends up being, I can simplify this. This goes away. So I'm left with 3 cube roots of 2. Notice that this right here is multiplication, okay? This canceled this, so I'm just left with 3. That's where that comes from. This 3 is right here, okay? And then we're left with the cube root of 2 under the radical. Now we're going to subtract. Oops, I got to write here. And this cancels this, right? So I'm left with 2 on the outside times the cube root of 2. So now check this out. We've got the same index, we've got the same numbers under the radical. Now we can go ahead and subtract 3 minus 2, and you end up with 1 cube roots of 2, or you could write it as just the cube root of 2. Okay? This right here is the most simplified way to write this. We understand that there is a 1 in front. We don't have to write it though, okay? All right, let's look at part B. Okay, so again, I want to turn this into something that hopefully matches, because as it is right now, I can't add these together. Okay, so I'm going to do a factor tree for 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. All right, so here we have the fourth root of 2 to the fourth power times the fourth root of 3 plus, now off to the side here, I'm going to do a factor of 3 for 243. I don't know about you guys, but I'm going to grab my calculator for this one. 243, 2 won't go in, so let's try 3. Yep, that works. and then I've got 3 times 27, and then I've got 3 times 9, and then I've got 3 times 3. So that would be 3 to the 1, 2, 3, 4, fifth power. So we've got the fourth root of 3 to the fourth power times the fourth root of 3. Because remember, you add these exponents and you get 5, right? Okay, so now we can take the fourth root right there. Those cancel, and I am left with 2 times the fourth root of 3 plus 3 times the fourth root of 3. Now, do a mental check here. The indices are the same. The radicands are the same. So now we can add the 2 and the 3 together. Okay? So we get 5 fourth roots of 3. There we go. We're done. All right, so on this one, let's not worry about part B right now. Let's just do part A. And we need to, we can't add them in the form that they're in because they don't have like radicals. So let's simplify this right here first, okay? That's all we're worrying about is the cube root of 24x to the fourth. Okay, so the cube root of 24x to the fourth can turn into the cube root of, let's see here, let's make a factor tree. So that would be 2 to the third power times the cube root of 3 times the cube root of x to the third power times the cube root of x. Okay? Remember, our x's have to add up to be 4. All right. So we can take the cube root of that. So the cube root of 24x to the fourth turns into 2x cube roots of, what do we have left over? 3 and an x. All right, there we go. That's what the cube root of 24x to the fourth turns into. Now let's do the cube root of negative 81. All right, so I'm not going to worry about the negative just yet, okay? So I've got, let's see here, 3 and 27, 3 and 9, and 3 and 3. Okay, so negative 81 can turn into the cube root of negative 3 to the, is that fourth power? No, that wouldn't make it. Let's do, hang on, erase better. Negative 3 to the third power. There we go. Times the cube root of 3. Okay, right? Now do this math. Negative 3 to the third power would give us negative 27. Negative 27 times 3 would give us negative 81. So that does work. Okay. All right. So now let's do the x's. Times the cube root of, let's see here, x to the sixth power, because I can easily take the cube root of x to the sixth power, times the cube root of x, because I needed one more. There were 7 x's altogether. All right, so now this simplifies to be, let's see here, that can go away. So I'm left with negative 3 on the outside. This can turn into 2, so then I've also got an x squared on the outside. And then on the inside, I've got a 3 and an x. Okay? All right, so now this is what we're subtracting. We're subtracting this and this. All right, now I'm going to rewrite it better. Okay, so 2x to the third cube roots of 3x minus negative 3x squared cube roots of 3x. All right, now here's the thing. Do we have the same index? This 3 looks terrible. Hang on, let me It doesn't really look like it. Sorry, I want to make sure that it looks like an index and not an exponent for the x. All right, so we have the same index there and there, right? We have the same radicands there and there. But here's the thing. The rules still apply whenever we combine like terms. This has a 2 and an x, and this has a -3 and an x squared. Can you combine those? No, because this doesn't match this. So guess what? This truly is the most simplified form of this answer that we can get. It cannot be simplified any further. Okay? All right, that's it for that one. All right, now this is the place where you want to either hit pause and write things down, because I'm going to erase this page. I don't have enough room to work part B. So hit pause if you're still writing. Otherwise, let it go, and I'm going to erase this work. Okay, this video is getting kind of long, and so I wanted to do at least the this part, the tree, the factor tree, without showing it to you, because I feel like everybody in this class should be able to do a factor tree on their own. In doing that, I discovered a problem with this one. So the thing is, if we had left it as 516, we wouldn't get very far with this problem. Nothing would ever match. There'd be nothing we could do. This is pretty much as simplified as it could get, okay? So if I make it 512 though, then it's actually a problem that we can do things with, all right? So I'm gonna change this example from 516 to 512, and then that way it's something we can work with. All right, so let's simplify the fourth root of 162y to the ninth. All right, fourth root of 162 y to the ninth can be written as the fourth root of, and notice I've already done this part here. Let's see here. 2 times the fourth root of 3 to the fourth. By the way, we're dealing with the fourth root, so we need to be very aware of whether or not we need an absolute value bar at the end, okay? Times, let's see here, we've got some y's in here, times the fourth root of y to the eighth, because I can easily take the fourth root of that, times the fourth root of y, because I needed one more, okay? So I can take the fourth root of that, I can take the fourth root of that, so those are going to go on the outside. So I've got 3y squared on the outside, and then I have the fourth root of what's left over, which is 2 and y. All right, so that's what that simplifies to be. So now let's look at the fourth root of 512y to the fifth. All right, so this can be written as the fourth root of 2 to the eighth times the fourth root of just 2, because I needed one more, times the fourth root of y to the fourth times the fourth root of just y, because I needed one more of those as well. All right, so I can take the fourth root of that, which is going to be 2, and I can take the fourth root of that. So that leaves me with, on the outside, 2 squared, which is 4. And then I have a y on the outside. And then remember that y is to the first power. So we're going to go ahead and put absolute value bars around that. And then I've got the fourth root of, let's see here, what's left over? I've got a 2 and a y. All right, so now here's what we're doing. We're doing 3y squared times the fourth root of 2y plus 4 times the absolute value of y times the fourth root of 2y. Now, the indices match, the radicands match, but notice this is y squared and this is y to the first power. So I can't really do anything else. This is truly as simplified as this answer gets. And I know what you're probably thinking. You're probably looking at that going, I don't see how that is any more simplified than that. And I kind of agree with you. But truly, this is the simplified form. All right, that's it for this video. I know this was a long one, and thanks for sticking it out. If you have any questions, don't hesitate to reach out to me.